power function of degree n is a monomial, meaning it has only one term. And its function takes on the form f of x equals a x to the n, where a is a real number and n is greater than 0. So here's some examples of power functions. For example, I have f of x equals 3x. Its graph would look like a line with positive slope. I have f of x equals negative 5x squared, right? It would look like a flipped upside down parabola. Here we have a degree 3 equation, so a cubic, and 6x to the fourth, that's a degree 4 equation. But we haven't seen what this looks like before, so let's take a look. A degree 4 equation looks a lot like a degree 2 equation, and a degree 5 equation looks kind of a lot like the shape we'd expect a degree 3 equation to take on. Let's take a look at y. So if I have x and y, I meant y like WHY. Let's see why it looks this way. And I plug in our standard x values. Negative 2 to the fourth is going to be 16. Negative 1 is going to be 1, 0, 1, and 16, right? So it still takes on that symmetrical shape. It's just that our second term stretches up faster. The same thing is true for x to the fifth. So if I have my x's and my y's, and we plug in our standard values, just kind of our basic ones, right? We know this graph hasn't been shifted horizontally or vertically because it's how it's written. So I know my origin's going to be 0, 0. Negative 2 to the fifth would give me a negative 32 way down here. Negative 1 to the fifth would give me negative 1. 0, 0, 1 is 1, and 2 is positive 32. So it still takes on that shape of a cubic even though it's degree 5. Here are some very specific properties of power functions. So when n is even, so for example, if I had x to the second, x to the fourth, x to the 24th, right, x to the 100th, it doesn't matter how big our n gets, my function is going to be even, so it will be symmetric to the y-axis when it's a monomial in the form of a power function, where a equals 1. My domain is always going to be from negative infinity to positive infinity, and my range goes from 0 to positive infinity. My graph is always going to contain the following 3 points, and it's always going to look something kind of like that. When n is odd, my function is symmetric to the origin. My domain goes from negative infinity to positive infinity, and my range goes from negative infinity to positive infinity as well. It's always going to contain the following 3 points, and its graph is always going to kind of somewhat look like this. One thing that's really important to find for a polynomial or a function in general is the zeros of our function, right? If I set my function equal to 0, this is going to tell me where my graph crosses the x-axis, okay? So let's say f is a function and r is a real number. This is like the important concept for the next 2 sections, so focus. And r is a real number for which f of x equals 0, then we call r a real 0 of f. And what that does is that makes x minus r a factor of f. If a factor occurs m times, it is said to have a multiplicity of n. So for example, if I have f of x equals x plus 3, we say that the real 0, negative 3, has a multiplicity of 2 because it occurs twice, right? It has a degree of 2. I could expand out that exponent. So let's practice finding some polynomials given their factors, okay? So I want to find a polynomial whose real zeros are negative 2, 7, 2, and 3. So f of x has a 0, right? So that means x, if I solved this, I'd get x equals negative 7, x equals 2, x equals 3. So in order to get these back set equal to 0, I've got to move my constants over. So I get x plus 7 equals 0, x minus 2 equals 0, and x minus 3 equals 0. This is going to be a degree 3 polynomial. So I've got x plus 7, x minus 2, x minus 3, right? And eventually this will just become habit. Like I said, if r is a 0, then x minus r is a factor. So because 2 is a 0, x minus 2 is a factor. Because 3 is a 0, x minus 3 is a factor. X minus a negative 7, well, that gives us plus 7. So we can go ahead and FOIL this out. I get x squared minus 2x plus 7x minus 14 times x minus 3. So f of x equals x squared plus 5x minus 14 times x minus 3. Now I FOIL again. F of x equals x cubed minus 3x squared plus 5x squared minus 15x minus 14x plus 3 times 14, which is going to be 30 plus 12, which is 42. Cool. Now I need to combine like terms. Apparently I did not give myself enough space, which I am prone to do. So I'm going to rewrite this up here, as f of x equals x cubed plus 2x squared minus 29x plus 42. And I was crossing out my terms as I rewrote them just to make sure nobody was left behind. Next, let's switch colors. I want to find a polynomial with real zeros 1, 2, and 4 that passes through the point 0, 4. So this is going to take a little bit more work. So I'm going to go ahead and switch this to a extra whiteboard. So my real zeros are 1, 2, and 4, and it passes through the point 0, 4. So when x is 0, y is 4. So we're going to go ahead and set this up as f of x equals a times x minus 1 times x minus 2, because those are my zeros, times x minus 4. And what we're going to do is we're going to solve for a. That's going to be our constant outside of our polynomial. That our polynomial is either stretched or shrunk by. So if I have f of x, that means y, right? So now I have y is 4 equals a times 0 minus 1. I'm substituting in 0 for x, right? 0 minus 2, 0 minus 4. So I get 4 equals a times negative 1 times negative 2 times negative 4. So 4 equals negative 1 times negative 2 is positive 2 times negative 4 is negative 8a. I divide both sides by negative 8. I get that negative 1/2 is a. So now I can find my true polynomial function by writing it as f of x equals negative 1/2 x minus 1, x minus 2, x minus 4. And I'm going to need to go ahead and FOIL this out, leaving my fraction for the last because nobody likes fractions. This is x minus 1 times x minus 2 is going to give me x squared minus 3x plus 2. Then I FOIL that by x minus 4. F of x equals negative 1/2 times x cubed minus 4x squared minus 3x squared plus 12x plus 2x minus 8. So f of x equals negative 1/2 x cubed minus 7x squared plus 14x minus 8. Then we distribute that 1/2. So I have f of x equals negative 1/2 x cubed minus 7/2 x squared plus 7x minus, so that's a positive because we're distributing a positive because it's a negative 1/2. My apologies. So negative 1/2 squared plus 7/2 x squared minus 7x plus 4 is our final answer for our polynomial.